Hello everyone and welcome to this course AMT 24-1 Engine Instrument Systems, and this is going to be module number 1, fuel flow indicating systems. Okay, so we're going to talk about the basics of fuel flow indicators, the different types of fuel flow indicating systems, and then we're going to have a general understanding of troubleshooting fuel flow indicators. We're going to access the aircraft engine manuals to see fault codes, and we're going to perform a sample troubleshooting, which basically is going to show you what a typical day of aircraft A&P technician is when you have an actual fault code and you have to troubleshoot and fix the airplane. And lastly, we're going to talk about test questions from the FAA test bank, just to give you an idea what those questions are going to be in your test later on. With that said, let's begin. So fuel flow meters in fuel injection engines. A fuel flow meter indicates an engine fuel use in real time. This can be useful to the pilot to assess engine performance and for flight planning calculations. The simplest fuel flow sensing device is used in conjunction with a fuel injection system installed in a horizontally opposed reciprocating engine. The pressure gauge is used, but it is calibrated in gallons per hour or pounds per hour. The amount of fuel that is flowing through the fuel injector has a direct relationship to the pressure drop across the fuel injector orifices. Therefore, monitoring fuel pressure at the injectors closely approximates the fuel flow and provides useful flow information for mixture control and flight planning. So as you can see from the image on the right, you have two fuel injections which are connected to the fuel system divider. There's a tiny orifice on the top. Basically, it compares ambient temperature to the temperature of the fuel, and then the gauge on the bottom, all it is just a pressure gauge that is connected to the fuel system, and it internally just recalibrate it and convert it to pounds per hour. But in reality, it's just a pressure gauge. So this system is very simple, reliable, and inexpensive in a certain way. Next slide. So fuel flow meters and turbine engines. So the turbine engines aircraft experience the greatest range of fuel density from temperature variation and fuel composition. An elaborate fuel flow device is used on this aircraft. It measures fuel flow for accurate fuel flow indicator on the cockpit. The mass flow indicator takes advantage of the direct relationship between fuel mass and viscosity. As you can see on the right, you have some fuel flow indicator for aircraft engines, for turbine engines, I'm sorry. So mass flow indicators. So fuel is swirled by a cylindrical impeller that rotates at a fixed speed. The outflow deflects a turbine just downstream of the impeller. The turbine is held with calibrated springs. Since the impeller motor swirls the fuel at a fixed rate, any variation of the turbine deflection is caused by the volume and viscosity of the fuel. The viscosity component represents the mass of the fuel flow. So as you can see, the fuel comes in, it spins the turbine, and there's some calibrated rings. The difference between the speed of those is what's converted by the computer inside the gauge to give you the fuel flow. Fuel flow digital gauges. So in the use of Microsoft microprocessors and computers on aircraft enable the integration of fuel temperature and other compensating factors to produce high accurate fuel flow information. The fuel flow sensing with digital output facilities with a high degree of reliability. Thermal dispersion technology provides flow sensing with no moving parts and digital output signals. The sensor consists of two resistant temperature detectors. One is the reference that measures the temperature of the fuel. The other one is the active reference, and it is heated by an adjacent element to temperature higher than the fuel. As the fuel flow, the active element cools proportionally to the fuel flow. The temperature difference between the two resistors is highest at no flow. So that's how it measures the fuel flow. And you can do a lot of calculations, gallons to destination, gallons to reserve, endurance. So this digital gauge have a lot more information than the old ones. Here we see a vane type fuel flow meter. Large reciprocating engines fuel systems may use a vane type fuel flow meter and measures the volume of the fuel consumed by the engine. This fuel flow unit is typically located between the engine-driven fuel pump and the carburetor. An AutoSim transmitter replicates the vane shaft rotation and the cockpit indicator that is calibrated in gallons or pounds of fuel flow per hour. So you can see it's very simple. It just has a vane, and the spinning of this vane just is converted into a fuel flow basically. Use a turbine type fuel flow sensor, a transducer, and microprocessor for the control functions that are located in the base of the turbine fuel flow sensor. The gauge is menu driven with numerous display options. So you can see it's another digital gauge, gives you a lot of options for the pilot to calculate fuel flow. Okay, now we're gonna go into a couple of troubleshooting scenarios. Here we're gonna have a Boeing 707 engine number 2, which is a CFM56-2A. The fuel flow issue is for oscillation 023, fuel flow high at idle. Uh, so if you're an aircraft technician and you're gonna go out to the aircraft and fix this problem, first you have to make sure you have the proper training to avoid any safety risks or damage to the aircraft. It's very easy to damage all this equipment in the airplane is very sensitive, so make sure you have the proper training. Take a look at the engine exterior, make sure the cowls are open and the area is accessible. You have to have training just to open the cowls. It's very dangerous and you can create damage to the airplane if it's not done properly. Make sure you have the proper tagaouts for fuel system. Consult the OEM manuals or the company policies. Uh, and then we're gonna access the OEM manual to the approved technical data to do the isolation. Also, make sure you voucher the work and the company's ERP system. It's very important that you, as an effective AMP technician, once you start a job, all these times are already standardized, so they know more or less how much time it takes. If they don't have such a system, then you don't have to worry about it. But if they do a voucher system, make sure you voucher in and out of the job. They're gonna require that from you. Okay, so now we're gonna go into the engine manual and see these codes. All right, so this is the actually let's open first the dash 2A. So this is manual. This is CFM56-2A. For you to open this manual, there should be a computer. This computer is just gonna double click on the icons. This is the way the icons look for the CFM engines. You double click and then you're gonna have this manual open up. Make sure you check the revision. The company needs to have a system in place for tracking revisions. So again, you have to have training and making sure that you know how to find out what's the latest revision. If you use the wrong revision, it is entirely your responsibility and you can get in trouble. So make sure when you start at the company, they tell you how to find the latest revision. Another way that you can check is you can go to the engine manual at the beginning of the manual. You're gonna go to from matter, history of revisions. There should be another training on how to use this manual in more detail. So I'm just gonna browse through it and imagine that you already know how to use it. And so in history revision, you will see all the revisions. As you can see, there's a revision every year, but this can be every 6 months, every three months. So once you see more or less the time frame of revisions, you will see that whatever day you're doing the work, you should be within the revision. If, like for example, this manual was 78, but you're actually working today in 2022, I mean, you're completely expired. But this is an old manual, so this is just for training purposes. But if you go to the history revisions, you can actually find out if the manual is the latest one and the one that you are allowed to use. Okay. So now we're gonna go into section 7200. Okay, we're gonna go to fault oscillation and fault oscillation 25. Actually, it was 023. 023, we're gonna hide this menu. We're gonna show the images. Click on this one. Okay. Right. So this is a fuel flow high at idle. So if the engine is at idle, you shouldn't have a high fuel flow. High fuel flow is when you're using a lot of fuel, meaning takeoff or cruise speed. Basically tells you you don't need any special tools, you don't need any standard tools. And this is the diagram to troubleshoot. So basically, make it a little bit bigger. Okay, so fuel flow had idle, RPM normal. So if the engine is just idling and you have high fuel flow, are there leaks present in the fuel manifold piping? Obviously, if you have a fuel leak, you have a lot of fuel coming from the tank into the leak and into the floor. So that's dangerous. So yes, then you repair the leaks. If you say no, are the HPT Schrock clearance control airlines and LPT stage cooling airlines serviceable? Yes or no. Repair the lines if there's a leak. Check the VSV and the VVV static rings. Are they within limits? So this is going to be about rigging. Of the VSV is going to be the variable stator vanes, and VVV is going to be the variable bleed valves. So you have to do rigging. Maybe they're off, means they're in the wrong position. So if they're fully extended, you're going to have more fuel flow. You have to check the actuators, the VSV actuator system, to make sure there's no leak and they're serviceable. Believe it or not, the actuators on these systems are operated by fuel. So if they're leaking, that means you're gonna have high fuel flow, and then if you have a problem, then you have to repair those. And lastly, you have to do a bore scope of the high pressure compressor, booster, combustor, HPT. This is basically saying that if the engine replace the defective module, so basically the engine is bad as a whole. Normally, I don't think you get into a high fuel flow problems when the engine is just like ready to be overhauled. Most of the time, you have a high EGT problems, but they have it here. Or if you still do a bore scope and there's not a problem, then you're gonna go to the computer system. So I don't know, they call it MEC, but engine is the mechanical engine control, sometimes the EEC, electronic engine control, but this is basically the computer. So these engines are very old. Let's go to maybe a little bit newer technology. So let's go to the 7B. So again, we're gonna go to the engine manual, file isolation, and let's go to, okay, so here we have file isolation 69, fuel flow signal out of range. This actually is a typical problem that you'll see in these engines. Let me remove this menu right here. And so it says, so now it's called the EEC, it's the electronic engine control. Let me see if I can have a picture. Okay, let me maximize. Okay, zoom in. So the electronic engine control is on the right side of the engine. This is a 7B, CFM56-7B. This typically is installed in a Boeing 737-600, I think. So as you can see, this is the EEC. First picture is going to show you where the fuel flow transmitter is located. This is on the left side of the engine. It's always standing up facing forward, so on the left side. And it gives you another highlight. Here's where the fuel flow transmitter is located. So let's go back to the instruction. It says the possible causes is single channel. It can be the fuel flow transmitter, it can be the EEC, or the wiring harness. So to do troubleshooting, you have to test everything. Most probably, you're just gonna start testing the harness or the fuel flow transmitter, and you're gonna go through all the steps. Here, you're gonna inspect the fuel flow transmitter receptacle, which is the pin, the connector, in the J5 wiring harness. So make sure the connectors of the fuel flow transmitter are tight. Disconnect the J5 wiring harness electrical connector from the EEC and the fuel flow transmitter. Do a visual inspection of the fuel flow transmitter receptacle to make sure you don't have any pins that are burned or bent or damaged. If the fuel flow transmitter receptacle is damaged, replace the fuel flow transmitter. You're gonna go through all the steps, and then there's a step here that you're gonna check the pins. So let's see what the J5 connector is. Okay, here we go. So J5 harness connector. So it's this one here in the back. You're basically gonna remove the safety wire, unplug this, and then you're gonna check the pins Once you open it, actually in the same plug, you will see the numbering of the pins in the plug. So then you're gonna check with an ohmmeter. We're gonna check pins 1 to 2. You should have this range from 300 to 400 ohms. From pin 1 to 3, 300 to 400. From pin to the connector shell, you're gonna be greater than 10 mega ohms, and then you're just gonna keep going through the checks. You're gonna do another resistance checks in the other side of the other end of the wire. It's gonna say pins S to R, R to P. So you're gonna be walking around with a multimeter quite a long time on these engines, checking pins. After that, after you do all the checks, if everything checks out with the wire harness, it tells you here if the EEC receptacle is damaged, then you have to replace the EEC, or sometimes there are focals here, but sometimes they're not. So you have to check the wiring harness and troubleshoot the core. It might be the computer, it might be the fuel flow. The fuel flow meter. Don't expect, don't assume that it's always the fuel flow meter. Also be careful if nothing works and you don't. One thing is to take out these EECs. It's a major job. It's pretty complex. You could, as a last resort, get a fuel flow transmitter, swap it out, and test it. You have to be careful because this fuel flow transmitter keep fuel inside. If that doesn't work and you have to return the fuel flow transmitter to the stock, it's gonna have fuel inside, so that's dangerous. Make sure you clear out the fuel. So basically, that's what you typically do. Once you find the fault code and you install the fuel flow transmitter and the system checks out and you clear the warning message from the cockpit, there's going to be another test. They're going to group all these tests in maybe an engine run. We're going to confirm, and if you did your job, it should work. So now let's go back to the test questions. Okay, test question from the oral test question number 15. What is the reason for monitoring fuel flow? So why would you want to monitor fuel flow? So fuel flow is gonna give you you can monitor the operation of the engine, right? So the answer, fuel flow is indication of fuel consumption and engine performance. Of course you want to track that, right? What type of readout is indicated on a fuel flow system, right? The amount of fuel flow in pounds or gallons per hour. So it's not gonna be PSI, that will be pressure. This is going to be converted to a fuel flow in pounds or gallons per hour. The per hour is the time version of the measurement because you want to see how much fuel in a certain amount of time. So this test question says the fuel flow meter used with a continuous fuel indication system installed on an aircraft horizontally opposed to reciprocal engine measures the fuel pressure drop across the A is going to be manifold valve, B fuel nozzles, C metering valve. We discussed this in the previous slides. You should know the answer. And the answer is B, across the fuel nozzle. The principal fault in a pressure type fuel flow meter indicating system installed on a horizontally opposed continuous flow fuel injector aircraft reciprocating engine is that a plugged fuel injection nozzle will cause a normal operation indication, highly unlikely, B, lower than normal fuel flow indication, and C, higher than normal fuel flow indication. What do you think the answer is? C, higher than normal fuel flow indication. So the fuel flow meter using in this type, so if it's plugged, the pressure drop across it would increase. And even though the actual flow has decreased, the flow meter indicates a higher than normal flow. And it does that because it is really not flow, it's just pressure that is used, that the gauge converts to flow. So if something is plugged, that means you have a lot of pressure. So the when you troubleshoot, you're gonna see that you have it's high, but it doesn't mean it's right. So you have to find a way to troubleshoot this and find out, because that means you have a clogged fuel injector. Sorry. In aircraft equipped with a pressure type fuel flow indicating system, If one of the injector nozzles becomes restricted, this will cause a decrease in fuel flow with a decreased fuel flow indicator on the gauge, B, an increased fuel flow indication of the gauge, and C, no change in the fuel flow indication of the gauge. So what is the answer? B, an increased fuel flow indication of the gauge. Next question, on a twin-engine aircraft with a fuel-injected reciprocating engine, one fuel flow indicator reads considerably higher than the other in all engine operating configurations. What is the probable cause of this indication? A. Carburetor icing. B. One or more fuel nozzles are clogged. Or C. Alternate air door stuck open. Answer is B. One or more fuel nozzles are clogged. What are the basic components of an engine fuel flow system? Read only two: a transmitter and an indicator. Next question, motor-driven impeller and turbine fuel flow transmitters are designed to transmit data: A. Using aircraft electrical system power, B. Mechanically, or C. By fuel pressure. Answer is A. Using aircraft electrical system power. Next question, the fuel flow indicator rotor and needles for a motor impeller and turbine indicating system is driven by A. An electrical signal, a direct coupling to the motor shaft, a mechanical gear train. Answer is A. An electrical signal. The fuel flow indication data sent from motor-driven impellers and turbine and motorless type fuel flow transmitter is a measure of A. A fuel mass flow, B. Fuel volume flow, or C. Engine burner pressure drop. The answer is A. Fuel mass flow. So the fuel flow meters take this into consideration, both the volume and the density of the fuel. That's why fuel mass flow.